Let's do one example of the tangent identity. So here is a reminder of the tangent sum and difference identity. Tan of theta plus alpha equals tan theta plus tan alpha over 1 minus tan theta times tan alpha. And if instead we had a minus sign in between here, then we would change all of these. There'd be a minus on top and a plus in the bottom. Okay, example, given sine theta equals 1/4 and cosine alpha equals 3/5, find tangent of theta plus alpha. All right, we need to start by drawing our triangles. There will be two separate triangles. We need a theta triangle and an alpha triangle because we have two different angles here. It matters. So, toa. We can label the sides of our triangle. This would be the opposite, which is for theta, it's 1. This is the hypotenuse, which for theta is 4. And this is the adjacent. We will have to use Pythagorean theorem in a minute to find that. This is the opposite. We don't know what that is for alpha. This is the adjacent. We know that that is a 3 for alpha, and the hypotenuse is a 5. Let's use Pythagorean theorem to find these numbers. All right, let's do our tangent identity now. So I am going to write it out. This is going to test a lot of your algebra skills. All right, replace your tan thetas and tan alphas with their TOA fractions. Make sure you pay attention to which triangle you're in. So tan theta is the TOA fraction from the theta triangle. So that would be 1 over square root 15. All right, tan alpha. This is the TOA fraction from the alpha triangle. All right, in the bottom we have 1 minus, again, tan theta, replace it with your TOA fraction from the theta triangle. And, oh, you can't see what I'm writing. And then tan alpha, this is the TOA fraction from the alpha triangle. All right, if you got this far, good, but now we have to practice all of our math skills here. You cannot just cancel out these 1 over square root 15s and this 4/3 because you have a plus and minus here. You cannot cancel willy-nilly when you have plus and minus. Everything has to be multiplied if you want to cancel. So instead, what we're going to do is come up with a common denominator on top and a common denominator on bottom. And when we do that, then we can keep, change, flip, and then cancel everything. Sounds like a lot of steps, and it is, but it's doable. We can do it just a little bit at a time. Okay, so common denominator on top. I need a square root 15 here, which means, ooh, this is going to be really messy. I'm going to need a square root 15 there. I need a 3 here, which means I need a 3 here. So I'm going to rewrite the top part real quick just for you to see. This is 3 plus 4 square root 15 all over 3 square root 15. So that's just my top fraction right now. On the bottom, if we want a common denominator, I need my 3 and my square root 15 on the bottom here. It doesn't matter what order you write it in. I'm just used to writing numbers before square roots, so that's why I put the 3 first. But they both have a 3 and a square root 15 in the bottom, so now I can rewrite that bottom fraction as 3 square root 15 minus 4. And the common denominator is 3 square root 15. All right, so some of y'all are really good at knowing when to cancel things and can probably already see what we have to cancel. I am not one of those people. I get it mixed up all the time. So this was first. Let me write my step just so you can see. When we do proofs later on, you'll notice we're going to have to do these steps over and over and over again. Write our steps, but it also helps make it clearer for anyone who's learning what's going on. So I found a common denominator on the top and a common denominator on the bottom to get these two fractions here. Well, this weird double fraction. And now it's one fraction on top of one fraction, so I can change my fraction bar division sign to a multiplying and flip. Keep, change, flip. So keep this top fraction as is. Instead of me dividing now, fraction bars mean dividing, I'm going to be multiplying and flip this second fraction, this bottom fraction. All right, and from here, the whole point of doing this is so that hopefully things will cancel. They don't always, but actually when we do the tangent identity, usually things will cancel, specifically the denominators, which this is now a numerator, not a denominator. But you have to be able to cancel a whole entire set of parentheses if you want to cancel something. All right, I'm going to rewrite this. And there's not any way for me to simplify this or factor anything out or even pull out a -1 or anything to simplify it even further. So this is my final answer. It looks really messy and not very helpful, but that is the algebra correct, exact, full answer for what is tan of theta plus alpha.